Greetings to everyone and welcome to the Guest Lecture Series 2021, an initiative by Technovanza VJTI. This lecture is co-hosted by Gaya College of Engineering and Engineering College Ajmer. This is Ananya Pawar and I am thrilled to be your host for today. VJTI was established in the year 1887 and it's upholding its proud legacy over a century filled with brilliance and educational prowess. Furthermore, it has thrived in nurturing the brightest minds of the society. Technovanza has always been the prime platform where the flame of expertise has been meritoriously passed on to light-more torches. The renowned lineup of the guest lecture series over the years has added immense value to the lives of several young minds, pioneers of diverse fields, including Dr. APJ Abdul Kalam, Dr. A.S. Kiran Kumar, Mr. Ratan Tata, G. Madhavan Nair, and many others have graced Technovanza with their presence. Amplifying this extraordinary legacy, we are very proud and gracious to host an accomplished aerospace engineer and rocket technologist, the phenomenal Dr. S. Somnath. Dr. Somnath is currently the director of Vikram Sarabhai Space Center. Sir has also served as the director of Liquid Propulsion System Center in Thiruvananthapuram. Till 2015, Sir was the Associate Director of Vikram Sarabhai Space Center and also the Project Director of GSLV Mk3 launch vehicle. The first experimental flight of LV M3X Care mission was successfully accomplished under Sir's guidance and leadership. Sir is an expert in the area of system engineering of launch vehicles. He is also known for his contribution to launch vehicle design, particularly in the areas of launch vehicle system engineering, structural design, structural dynamics, and pyrotechnics. As director, Sir has mentored the team to develop the Small Satellite Launch Vehicle (SSLV) with innovations for cost reduction and production easiness. Some of the significant tests accomplished at the Pad Abort Test P8001 over the Gaganyaan. The successful first operational mission GSLV Mk3M1 for Chandrayaan 2 with payload enhancement was a significant event. Sir, this small introduction wouldn't do enough justice to you. You have blended the eloquent qualities of hard work and persistence with absolute sublimity which can never be unseen. We are truly honored by your presence today. We will have a Q&A session after the lecture, so please leave your questions in the live chat below. Sir will be sharing his expert outlook on the topic Indian Space Enterprise New Vision and Direction. So without any further ado, let's be a part of conversation talking about our shared future under the guidance of clearly the best. Over to you, sir.
Thank you, Ananya. So let me go straight to the talk. I hope that my presentation is visible. I'll put it in the full screen mode. So the topic I selected for today's talk is the Indian Space Enterprise New Vision and Direction. And this is very, very important today that in India, we had a new announcement by the government on how to reform the space activities in this country in this direction, especially when I talk to young people. I would like to tell the views of the government as well as the preparedness that we have in ISRO towards moving towards a new vision. So that's my theme of my talk. I hope that I'm able to change to my next slide. The next slide talks about the Indian space activities so far and what is next in for us. See, all of you know that we started the space program in 60s, 70s, when the Americans and the Europeans were still, very, very developed space nations having capability to build huge rockets and take man to moon. At that time in India, we were just building small rockets, sounding rockets, and also building the small satellites like Bhaskara 1 and launching it through other nations' support. But over the years, last 50 years, we have developed a lot of capability in terms of launch vehicles, spacecrafts, applications, and we built huge infrastructure, enabling us to design any rocket that we want and also any satellite that we want to be built and to be launched from our country. So it's a huge capability that we have developed. We also made missions like going to Mars. The very first attempt, we became successful in placing our satellite around the Mars, went to moon, had the moon impact probe. Of course, the Chandrayaan-2 had a certain amount of issues, but then we are getting ready for the future. So considering all this, I would like to address very quickly what is next for us. Okay. So all of this, what we achieved in the last many years, have been summarized into a single PowerPoint slide, which talks about 191 space missions we did. We have all the array of satellites. And the most important thing to note is we launched almost 319 foreign satellites from 33 countries. We could accomplish that. With certain number of satellites to do certain functions, and they have to serve the country and the users for a very long time and producing some output. So let us look at what are the outputs out of this whole activity. Look at communication area. We have 17 satellites right now doing the high throughput satellite communication, especially in internet services, direct to home services, and also communication service across major cities. We have Earth observation satellites, 25 of them. Some of them are working for very many years, very successfully, and some are nearing their end life, but they are serving us in different spectra and giving a lot of observations in visible, infrared, as well as radar observations. We have navigation satellites, 8 of them, which is serving us in the NAVIC, and also the science explorations, Chandrayaan-2, Mars Orbiter mission, and AstroSat, still working very well. So 53 satellites in orbit, and we are managing all of them on a day-to-day basis, 24/7 basis. We are observing them and collecting the data and managing the entire support systems as well. We have a huge technology spread in the ISRO, capable of designing in various domains, aerodynamics to electronics to manufacturing, propulsion, chemicals. You talk about any area of engineering, we have somebody or the other, a team capable of designing and developing ourselves within ISRO. But then everything what I talked about is the accomplishment, but there is a change happening all around the world. And how good we are in understanding the change and then adapting ourselves in looking at how to remodel the space activity in this country. So let me tell a few points about the changing environment. I hope that you are able to see the slide which talks about changing scenario space applications. And look at the satellite systems. The data products from the space are to be delivered to the user instantly. Earlier, we sent off an application for a set of data. It will come after a few days, weeks, sometimes. But nobody is able to wait so much. Over the web, you need to get the data. We need to get streaming videos, especially when you're traveling in flight. You need to have the video connectivity. We need to have the integration of the video with the satellites images, the drones, as well as terrestrial imagery. So the streaming video should come through any of this route without realizing where from it is coming. Communication to individual has to happen. So web connectivity through satellites, that is something which we are looking for, and very accurate and very reliable timing and position services is essential. For example, GPS, NAVIC, all of them have to become very reliable and very accurate. And it has to meet all the demands of the transport sector as well as individual requirements. Even for drones, it is very, very important. Now, another important area is satellites finally has to merge its applications into administrative support. For example, government, to do its function, a lot of satellite services are required. And spacecraft is also becoming the force for the nation. And it's a force multiplier for the defense system. And it can survive the boundaries. It can also support in actions, especially in providing backup support for our forces. So all of these are coming up in the future, and how we are getting connected to do all this is the question. Now, some of the disruptive work done by these individuals are something that we need to take note of. The SpaceX made the successful landing many years back, and now they are operating their launch vehicles very successfully, recovering them in the sea and reusing them. And they made a record recently, 8 times they have used their rocket. And same is the case with Blue Origin. Bezos is also developing his the rocket, and they have also successfully made their orbital mission first time. And the most important during the last year is 2020 is that SpaceX could do the first human space flight to space station successfully and bring them back using their new Dragon capsule. And all of these are changing the way in which the space technology is being looked at by countries, nations, as well as private enterprises all across the globe. So we are talking about reusable rockets. They are becoming commercially viable. So this is the most important outcome of the last few years. And everybody is now looking at how to build reusable rockets so that we can bring down the cost. Various options like vertically landing like the SpaceX did, and also looking at winged rockets which can come back and land in orbital places. So that's what everybody is discussing. And reusability brings in something like the aircraft economy. So because like aircraft goes from one airport to another and then take the passengers, so that we are able to travel very affordably. But it's not possible in rockets. So that, for one-time trip itself, you need to pay huge amount. Only multi-millionaires can only afford to think of traveling to the edge of the space and come back. But slowly, the technology is evolving to make it happen. Let me look at another important area where the space technology is going to revolutionize. It's in the area of drones. All of you, maybe some of you may be working on drones technology, how they can fly over long distances, how to navigate them, and how to use it for various applications, such as for medical applications, how to deliver medicines to critical people, and also even organ transportation they have successfully employed, delivery of the consumable goods, also do surveillance and security, transportation, agriculture area. Drones are very well utilized for seeding, the pesticide applications, etc. And drones are of different nature. Some of the drones will stay in air for months together without using any extra power from solar derived. Now assume a technology where you have millions of drones and all of them are flying around, and how to control them, how to regulate them. I think this is when the space technology will come into use, especially with an artificial intelligence driven backup engine. It's very much possible to control all the drones and then achieve a lot of economical activity using space technology. The space business all across the globe is something like $360 billion economy, in which our share is still very, very small. India's share is very small. I am not going to talk about the numbers involved here. But we know today the overall economy of the space technology, the satellite industry has a certain amount of share, but the launch vehicle industry share is very small. And most importantly, under the satellite industry, satellite building, GNSS, which is nothing but the positioning system, ground equipments, and data, in which you can see the data is the biggest value addition. So whatever data coming out of the satellite, how to make business out of it is something that we need to pay attention to. And similarly, the core technology area of building the satellite as well, we need to slowly move towards industry. So that's a message which I want to tell out of this. So today we look at the entire space enterprise of India, which is currently, the business volume is around 14,000 crores. So that's the budget the government is identifying for today, because there is nobody else doing space technology other than ISRO. But we want to enhance this whole of this provision to something like 50,000 crores per year. So where ISRO will basically contribute as a technology enabler, and industry will come in enhancing the value chain to building by rockets, building the satellites, building the applications, and then really increasing the overall market presence of space technology in India. So that's a goal, how the government is looking at it, all of us are looking at it, how to really increase this value chain. For that, new government has now brought out new directions. So there is Indian Space Research Organization, ISRO is there at one side as a pillar, and two more pillars are now being created. In space is one vertical of the whole of Department of Space, and NSIL, New Space India Limited, as a public sector unit. So basically, ISRO being a technology holder, they are doing research in space, they are doing developments, they are doing national missions. They have to now do a new role, which is nothing but hand-holding the new industry, new enabler of technologies. And in space is a regulator or authorizing agency where a new actor which is coming to this business, they will be enabled to do space technology. They will become a single window clearance, and they will allow you to do launches and building spacecraft within the rules and regulations of the country, so that the nation can hold responsible for all the activities done by space emerging industries. And NSIL as a public sector undertaking can become an asset holder of all the operations. They can generate revenue out of the market, what is being created. It can be a funding source for the industry, and also handle industrial production. So this is the new vision that has been recently announced by the finance minister. Now, what are the opportunities for industries and you people, startups and business in this country? For example, PSLV, we have a very small share of market, but it is still very critical because this is a capability that nation is having to launch satellite. Without launch vehicle, there is no space activity going to happen. And we are looking at how rockets can be manufactured by industries. Even today, most of the work is done in industry, but the aggregator of the technology, or even who is having the full vision of the whole rocket, is still with ISRO. And this is what we want to transfer to some industry clusters. So we are telling industries in this country to come and join together, multiple technologies. Somebody has some skill, somebody has some other skill, come together and come to us. We are ready to hand over you the PSLV rocket. Why don't you go and then manufacture them and launch on a commercial basis to the users world across. So this is slowly happening, and they are coming to us, and we had recent lot of discussions to take it forward. So this is something very interesting thing happening in space sector. So this is the way, whatever I described here, the NSIL, InSpace and ISRO will be organized under Department of Space, where we'll do various activities as I mentioned here. NSIL will look at as a commercial operator of all the assets that we have created. They will be the business holder. They will be the running like an industry, whereas InSpace will be running like a regulator and law enforcer, whereas ISRO will be the technology holder, having all the IP rights, and they will be working with international agencies and then have the design authority. They will also look at future exploration, human space flight, advanced technology, etc. And whatever infrastructure we have created in ISRO will be available to the space industries which are coming outside for sharing. So they don't have to spend a lot of money today to build new rockets. So that's a message I want to give you, young people. If you are interested to build rockets, you are welcome. And we are ready in ISRO to give you some of the facilities, maybe for a leased amount, for sometimes for a cost, or for a price, which you don't have to invest the huge amount required for creating it in the very first time. So that is something which is a deterrent to many space agencies to come up. And we want to make sure that young people who are starting new startups, I'll talk about them, they are not having a lot of obstacles in coming successful. Now in India, we are looking at how to productionize space system through industry, how to explore the commercial opportunities of space technology. And we want small satellite production to take place, satellite building to take place, commercialization of whatever technology we have developed in ISRO into industry. And we want the space people to look at applications. See, even apps that you are developing for extracting the information from satellites and make it available to users will extremely useful, and it can turn out into business. But a lot of issues are there in this. Whatever I say, it will not come out to be successful in the very beginning. And we are addressing each of the issues. For example, what startups can do? They just like that enter and then start building the rocket. When big businesses, industry houses are not able to do space technology, or they are not able to do rockets, what these startups can do, and how to become profitable here. If you build one rocket, two rocket, will it become profitable? Maybe hundreds of rockets sometimes you have to build. And how to globalize the production that you are going to have, and how to sell it to other countries, and various new technologies, how to take it into this area. So there are a lot of questions are being asked. Maybe this is a challenging area for startups to address. One example is satellite building. And satellite building is a very commercially viable technology. And many of you would have seen a lot of small startups have come up capable of building mini, micro, nano satellites, and they are slowly entering into this area. I'm sure maybe in the next 2 to 3 years, or maybe 5 years of time, you will see huge satellites being built in this country. I think the technology in satellite is not more complex than a mobile phone. I want to tell you, it is possible within the reach of most of the technical houses in this country. Another important area is remote sensing and data services, where the business can really grow. For example, you look at crop prediction, town planning, surface water mapping, climate modeling, fishing zone identification, mineral mapping, agriculture, and in all these areas, there are a lot of applications possible using the imageries from satellites. And all of you know possibly that our satellites are giving huge quantum of images to our data centers, and they are available to users if who wishes to use subject to the licenses of related to the critical areas we have to remove, and then commercial areas we can available. And if willingly people want to come into this domain, work on new applications, develop and market them, there is a huge possibility waiting for you. I want to talk about the space startups in India. Already 160 startups have been registered. Out of them, 33 are well funded, and all of them are ended up in very good deals with the users. Their market business have been almost 10 plus deals are been signed, and almost $10 million funding has happened in the last year, till last year. And they are into launch vehicles, they are into satellites, they are into data applications. So some of the names are well known to you, where they have already come up in your TV and also in media, and they talked about their vision and talked about their accomplishments and what way they want to go about. So it is something available in the public, so I am not going to talk about it. They are developing satellites and payloads, they are developing launch vehicles. Some of them are working on data products and their value addition, and even some of them working on propulsion systems as a standalone unit that can be supplied for users. For example, a satellite designer requires a propulsion system for satellite. That some other startups are working. So I told the startup people that why don't you come together and develop systems instead of distributing yourself into different domains. So maybe it will happen in the course of time. I think the dialogue is very well going around, and I'm seeing potential of many or some of them, at least some of them, to come up very successful in building rockets and satellites. Now come to ISRO. This is the scenario that is changing outside, but within ISRO we are becoming more and more of enabler technology, and we are willing to take up the mentor role. So the mentor role will be like this. Most of the work which we do in the lower part of the circle, that is a medium and small launch vehicle side, we want to hand over to the industry. So it will be commercialized through the NSIL, whereas the top part, the heavy and super heavy launch vehicles and related activity, will continue to work with the ISRO. So that much of the workload related to the production, launching of commercial activity will be given away by ISRO. And we will concentrate only on the futuristic technology. But at the same time, we want to work on very, very far future technologies like the air breathing propulsion, the fully recoverable rocket, air breathing two-stage to rocket, orbiter vehicle, etc. So some of this area we will continue to work. I will show you some more details about it. In ISRO, we are continuing to work on progressive growth of launch vehicle capacity. So all of you know, we have a capacity today to launch almost 4 to 4.5 tons of satellite to a geo transfer orbit, but we want to increase it to something like 6 to 7.5 tons, and possibly with the reusability. So this is the area we are working today. We are developing the semi-cryogenic engines and also looking at various technologies that will enhance our payload capability in the coming years. Looking at the winged rocket development all across the country, for example, Space Rider in US, ESA, Europe, Space Plane by the Boeing, the Virgin Galactic rocket. We have also been working on winged rockets. We did one mission, and we are getting ready for the next one for a runway landing experiment. Our vehicle is ready, and I am unable to show the picture today because it has to come in the press maybe at a later point of time, maybe a few months of time. And progressively we want to develop a rocket and a stage which will go to orbit and come back and land in a landing strip. So this we are working on. We have an approval from government. We are working on such a design which will maybe 1 to 2 years of time it will become a reality. We are also working on vertical landing concepts like what SpaceX has done. Of course, I must admit that we are late in this business because the confidence, it is true for all space agencies, because somebody brings up a very disruptive idea, then it has to be adopted to others. It may take some time. So same time we are also taking, but we are not losing the possibility into developing a vertically landing rocket using some of our available technology. So some of the interesting technology for it are variously very interesting. How to design a four-legged rocket which will come and land softly. How to design a vision navigation system using cameras and radar altimeters. How to locate your position properly on Earth and then come and land at a designated site. How to do remote filling, etc. So all the related technology for this vertical landing we are developing right now in ISRO. We are also developing a new autonomous scramjet test vehicle. Scramjet is a technology where there are no moving parts in the rocket. The air will be taken, it will be compressed at a hypersonic velocity, and then it will be combusted with a kerosene as a fuel, and we produce the thrust. The advantage of such an engine is that we can use most of the air from the outside, and our fuel quantity can be substantially reduced. That increases efficiency of the rocket. So that's the goal of such a propulsion system. We tested it once on a small scale. We are now working on that engine which I am showing this picture, which is a very huge rocket, and it will be able to travel at super hypersonic speeds. That is almost 6 to 7 times the speed of sound, to cover from my place to Bangalore in just 20 minutes. So that's the type of speed that it will achieve. And so we are working on such a design now. Maybe ultimately we will be able to take a fully air-breathing propulsion stage to orbit and come back using this concept, which will be a rocket, air-breathing, turbo-ramjet combination. So once you have such a rocket, it will be like an aircraft. You just go to take off from the runway, launch the first stage, and first stage will come back, second stage will go to orbit and inject the satellite. That also will come back after some time. So such an idea will really make the space travel really interesting and economic. Another thing you also mentioned about my work in the small satellite launch vehicle. Small satellite launch vehicle is a very interesting rocket. We wanted to develop it basically to bring down availability of rocket to users very, very fast. Suppose some of you are building rocket, assume, and you want to launch next week. You simply make a phone call and then we are ready for launch. So in just 2 days, we'll be able to integrate this rocket and go for launch. So that type of capacity we want to develop, and it won't take years to come to an agreement, then ready for launch. Nowadays, it takes that much of time. 6 months to 1 year is the cycle time required for preparing for a launch. It can be done in weeks or days together. So we are ready with the rocket. In another 2 months, you will see the announcement about its launch, and we will be operationalizing this SSLV through an industry in the coming days. We are working on human space flight. It is sufficiently being talked about in the media, so I'm not going into that. We are developing the human space rocket, GSLV Mark III derived rocket, and also the Gaganyaan module, where we can travel to space and come back. It is a very, very, very complex technology. First time done in India, and all of you know that this technology and elements associated with the Gaganyaan program or even human space program is not available for sale. It has to be developed in this country, and ISRO is working with all the stakeholders in this country. It's a lot of institutions, industries to develop system by system to make it happen in the next 1 year. This is the future rocket, which may take almost 23 tons to low Earth orbit, so that we can build space stations. Human presence can be continuously available when we really develop the capacity to go to orbit. So these are the array of rockets we are going to develop. On the yellow line, you can see on the left side, the 3 rockets are the one which we are currently operating. But on the right side, we are developing all of them today in ISRO. The SSLV, the reusable launch vehicle, the test vehicle, the Atmair, which is a vertical landing vehicle, the human space rocket to take the Gaganyaan, and the heavy lift rocket, which will build our space station, and the derived human space vehicle of the heavy lift vehicle. So all of them are the designs which are currently going on in ISRO. So I want to tell you that the Indian Space Enterprise currently is trying to create a space technology incubation industrial environment. What I mean by that is, by our work, we want to make sure that it is not ISRO alone that is capable of building space technology and systems in this country, but it can be done in an industrial environment, and we will create such an atmosphere in this country so that this can happen. And they are creating an innovation in space, in academia and industries to leverage on new services and products. See, probably you may be knowing that we are talking to many institutions, academic institutions, engineering colleges, IITs, to create space technology cells there and start research work from us on various ideas, and we are working with all of them. And we are also looking at schools where adult tinkering labs are created, interest in space technology is created. So a lot of work we are doing to popularize the space activity in this country. We also want this country to become a global space system delivery point where we can build rockets, spacecrafts, ground systems and applications, and actually become a selling place for the international customers. And we also are trying to bring international space industries to this country and start operations, because this way our capacity in industry will be enhanced. And we also looking at creating space-based services in a commercial environment. And ISRO will be the harbinger of and nurturer of technology and national needs it will meet. For example, if you want to look at the defense requirements in space, it will be the ISRO that will be meeting. Maybe in the coming days, it may be possible from industry services as well. So today, if you want to look at the space enterprise across the country, we want to look at big industries, startups, and ISRO in proportion to the square shapes that I marked here. The big industries must grow very big to handle much of the volume of the space infrastructure, and startups should come between the big industries and ISRO to transfer the technology from ISRO, get into a development stage, and then move to become big industries. So this is what we want India to happen in the coming days. So with that, let me conclude my talk. And now it is up to you for more questions and discussions. Thank you so much.
Thank you, sir, for such an insightful lecture. I'm sure I'm speaking on behalf of the entire audience right now that you have positively revealed groundbreaking thoughts and promising ideas while instilling a new perspectives in our lives. We'll now begin the Q&A session. So the first question is, sir, does ISRO have any plans to make NAVIC to a full-fledged global positioning system like the GPS and the BeiDON?
As of today, the architecture of NAVIC is as a regional navigation system. As you know, it is not based on a satellite which is at a medium orbit or a low orbit. It is basically using satellites which are reasonably stationary. It is at GT orbits or GSO orbits, and they are at the equator, always on top of India. So it is a regional system. So 7 satellites does the regional navigation. And satellites position is what relative position is what determines your position. So if you have to convert this NAVIC system or IRNS system into a global system, it is not possible by architecture. Only thing we can do is we can expand it region. For example, the IRNS now covers the Indian region plus 1,500 kilometers outside our boundary. That much area it covers. That 1,500 kilometer can be increased to say 5,000 kilometers. We can make spread over the regions of interest, but it cannot be converted into a global like the GPS. It is not possible.
Sir, so the next question is the news that NASA is sending man back to moon in 2024. After Gaganyaan, is ISRO also working to send the first Indian to moon?
See, you see, what's the point in stretching your leg before you know how to sit? So I will rather say that when I talked to you in the beginning of the slide presentation saying that we had a huge gap in space technology between US and India to start with. But then we have bridged that over the last 50 years in terms of building capacity for launch vehicles or satellites building. We have overcome that, and we are able to launch our own satellites from our own soil. But we still don't have human flight capacity. See, humans flight is a very, very challenging work because we can tolerate failures. We need to know how to keep them safe in the orbit for a very long time. It requires environmental control and life support system. We need to design a rocket which is capable of handling failures, bring them back safely in case of an abort or any issues. Then we need to prepare the people and the ground systems to enable this travel. For example, our astronauts are under training. They need to develop the skill to handle this. And we need to create a pool of such people over the next coming many years. So Gaganyaan is the first step towards such a capacity. And once you have that, we will think about it. I think in our map that we have the plan to take this human space activity to a higher level. That means we are talking about sustained human presence, Indian human presence in space. That is an agenda for us. So once you develop the Gaganyaan capability, we will have continued missions to space. It may be to a space station which you will build, or it may be to moon at a point of time. But that capability requires next many steps. It is not one step that is required. For example, to take human beings to moon requires huge rockets. It cannot be done by GSLV Mark III or GSLV or PSLV. It requires a next generation rocket, the heavy lift rocket which I mentioned. That is talking about only 24 tons to low Earth orbit. But really, if you want to take human beings to moon, we need something like 90 to 100 tons to low Earth orbit. The rocket which took moon to human beings to moon first time in the US, that was a huge rocket having a capacity to take 140 tons to low Earth orbit. Such a massive rocket. Saturn 1 was the one used by US. Today they don't have any rocket. All of you know that they don't have the Saturn. They have closed down all the program. Even the space shuttle program was not capable of taking human beings to moon. So it's a next step. We need to make investment for it. So I want to tell you that the first step is Gaganyaan. where we will have the capacity. In another 5 years, we may develop it and then nurture it to see that it continues and sustains. Then we will ask government, yeah, fund us somehow. We are ready to go to moon. And I'm sure you people will be the decision makers at that time. You will tell, okay, government, you give them money. ISRO will develop the rockets to go to moon, and we will take Indians to moon also. And ISRO must be ready to do that with the support of the industry. And I have no doubt about it. It will be done one day.
Thank you for the insightful answer, sir. So the next question is, how do you see the new space race, which is currently developing between SpaceX and ISRO, as the cost-efficient way to send satellites to space?
No, SpaceX is in race against all space nations. It is not against ISRO alone. No, SpaceX is challenging even NASA. You know that NASA has their own programs of various programs. For example, you would have heard about American space rockets, the Titan rocket, the Delta rocket, the Taurus. Now, all of them are really in the big issue because none of them are capable of competing with the SpaceX, because SpaceX brought out the idea of reusability. And they don't have any other reusable rocket in the world today. So naturally, there is an advantage to SpaceX. And ISRO also has the same challenge of competing with SpaceX in terms of per kilogram cost of satellite. Though their rocket is twice the cost of PSLV, but their offering cost to a customer is maybe 1/3 cost of what PSLV can offer. So it results in a market point of view very challenging. So we are looking at how to compete with the SpaceX initially by reducing the cost of PSLV, by doing it cost engineering and bring down the cost. But over the time, we need to develop reusability. The same hardware, if you use again and again, only then we can bring down the cost. The technology is still not with us. It is not with even Russians. It is not with the Chinese. It is not with the Japanese. It is not with any other country that is having capacity to launch. It is there only with SpaceX today. And the next person who has developed is only the Jeff Bezos in the Blue Origin. And it is important for us to go to that and then develop that in the next few years so that we can really be a competitor to SpaceX. Otherwise, they will overtake all the space agencies in the world, including ISRO, in terms of cost effectiveness. But I can tell you, with regard to national strength, we have the capacity. Any Indian satellite, if you want to launch, we can definitely launch. But we cannot compete in the open market because of this challenge which they are proposing, unless we do some important innovations which I mentioned in my presentation.
Thank you, sir. So the last question for the evening is, ISRO plans to launch its own space station in the near future. How is ISRO working towards it?
Space station requires, first and foremost, is building capacity. For example, space station is never built as a single piece. It is in piece by piece, you take it to orbit. You have to bring them together, then assemble them. Then next module will come and assemble. You need to do extravehicular activities. The astronauts have to come out with the suit, then do some work over the many hours and to assemble them. And slowly only it will be built. So what are the capacity that you need to build a space station? First, you need a heavy rocket to take a massive piece to the space. You need to have astronauts of our Indian origin who can do spacewalk. And we need to have a Gaganyaan module which will take them there. Okay, and we need to have extravehicular activity capability. We need to have robotic capacity to bring two pieces together and then dock them and then connect them and interconnect them. And that requires again another technology, vision, navigation, docking technology, etc. we are trying to develop. So what we thought is each of these we are split into various technology elements and we are trying to demonstrate them. First, of course, is Gaganyaan. We are also trying to demonstrate the docking technology by sending two satellites to orbit, and in the space they will connect each other and disconnect. So this is called the SpaceX, and we have the experiment already approved, and we are working on the satellite already. The proto models are realized, and we are doing that. The docking system technology is also part of such a technology. How to grab another satellite and connect with them using camera systems and navigation systems. So this is another area we are working. We are working on inflatable habitats. See, suppose human beings have to go and huge buildings, you cannot take it in a rocket. We have to fold it and then put it in the small ones. And once you reach a orbit, it will expand and become a huge habitat. So it is making of materials which is possible to expand them in space and rigidize them. It cannot be balloon because after expanding the full shape, it has to become like a solid material. So we are developing chemicals that can be used as a balloon. But once the balloon is reaching the orbit and sees the sunlight or the sun heat, then it will become rigidized. So such chemicals we are developing. So it's called the inflatable habitats, and a lot of such technologies we are developing. And one day we are hoping that we will be able to build this space station. We also have sketches of the space station which we want to build today, at least to dream about today, and we are working on element by element of each of those technologies.
Thank you, sir. Sir, we are truly honored by your presence today. Thank you for such an impactful and thought-provoking session. We hope you all enjoyed the session. Stay tuned for more such insightful lectures. I am Ananya Pawar signing off. Until next time, this is Technovanza VJTI.
Thank you so much. Thank you.
Thank you, sir.